take a quick look at our mold designer now. So in aerospace, automotive, anywhere that needs mold tooling, the actual design of the tool can take a lot of time. What we can do is take the mold surface or the actual final panel, and we can build a designed for additive mold around that. So we have our surface here. Alternatively, you can load in a step file and select the surfaces that you need to build the tool around. And then rather than slicing the part, we're going to feed it into our mold designer. So we selected our input surface. Now slicing settings, we can define what our different slicing settings are. And we also have staggered layers, and I'll touch on that in a minute. I'll just go to a bird's eye view for a second. We can define our extension lengths, which is the bits on the sides here, and the mold depth, which is the distance from the bottom of the surface to the back of the tool. We can add stiffeners. We can define what those stiffeners look like. We can even add air gap. So if it's like an autoclave tool, you need really good airflow around it. We can define what those air gaps look like. We can add forklift pockets, extra walls, all sorts of different things. So let's just cut to the chase and take a look at the output. Yeah. So we can see we have, in a few seconds, gone from a surface to an entire 3D printable tool. We have our nice surface here. We've got our stiffeners, forklift pockets, and then I mentioned staggered layers. If I go to the surface here, we can actually see that the wall behind the front wall is at a different height. Yeah. And that is done on purpose with the staggered layers. So you kind of have this bricklaying effect, and it means that when you're milling your outer surface to give it the finish that you need, you are going to minimize the porosity that you would normally get between beads in that gap that you normally get from stacking them side to side on top of each other. So this is something that we did R&D for in-house, and we've finally added it to the software, and it's a really fantastic feature. And it's all done automated, and I believe even, for example, the layer height on the bottom is smaller in order to achieve that effect. So it's all parametric based on the layer heights that you provide. So it could be done manually if you really wanted to. You could filter out layers and change the thickness and all this stuff, but here it's all automatic.
You can also do scanning actions, Danny, to the jumps?
Yes, so in our toolpath operator, under movement speeds, sorry, not under movement speeds, under jumps, we have scanning here. So this is commonly referred to as wiping. So at the end of a polyline, it will wipe on the close of the polyline or on itself if you want to as well. And you can define the speeds and distance that we do that. So that helps close things off, reduce oozing, clean things a lot better. And that could be combined with our deposition controls here. So a lot of our customers will use this deposition before end and actually turn off the extrusion a small distance before the end of a polyline so that they're not over extruding at the end. So a lot of extruders don't come with melt pumps, and there's just natural back pressure in the extruder. And we have got lots of features and settings that we can use to minimize the defects of different kinds of combinations of hardware. So a couple of things we can do to this tool is change our corners. So we've looked at curvature compensation, but here we've got a different use case for it. Because we're all printing with round nozzles, we get rounded edges. And sometimes that means that your milling offsets aren't uniform like you need them to be. So we can filter out the walls that we need here, just the outer wall. And then we can apply a curvature compensation. So here it's quite dramatic, just so we can see it happen. But it will apply this little kink to the toolpath.
Yep.
And that means when it comes to actual printing, you now have enough milling stock in that area. So it'll be milled properly.
Yep.
We can also make the path continuous. So we've combined our infill reinforcement ribs and outer walls here We actually already have that setting continuous mode in here, but we can always do it after the fact. That's part of the flexibility of the whole software, is you can order it how you want. Sometimes you want to make a change later, depending on all the other changes that you need.
That's the thing. Now we have all of this. Everyone now is doing a lot of non-planar, multi-planar, not so much continuous, but control. But if you don't have the right architecture, you will find a wall very quickly of the amount of designs you can use. And we've seen it over the years doing it, that you need to have that kind of architecture and know how to develop it accordingly.
Yeah, exactly. So we have the same workflow here, but for a robot. And that's also another feature. If you have multiple hardware options in your factory, in your workshop, you can simply change the machine that you're using in the workflow, and it will recalculate for that new machine. So here, with our safety checker, we can, for example, pick up some errors based off the location of where we're printing. So in this case, we have an axis limit and a wrist singularity. And we're very confident in checking those. And it's because we're a bit close to the robot, so it's having to do some awkward positions. So we can move our meshes, but we can also move our polylines. You can see we can move them to where we need to. Here I've purposely moved it to a very awkward location for the robot to show that we can also check for reach limits, and we can visualize those very cleanly as well. So if I go here, it is pinging up with lots of different errors, as we expect. And it's just loading our reach analysis. So we've got our reach limit issues. And you can see it's highlighting the specific areas of the print that it can't reach.
Yeah.
So sometimes if you're doing very tall parts or very long parts or a combination of, you need to know what it can and can't reach. And of course, here we know it's in a terrible location, but it's incredibly useful information. And then finally, we move it to somewhere very sensible. We can stop teasing the robot, and we've got a nice green shield, and we can print the part just fine.
Very nice.